Last video I had left off and I had said we were talking about slope and derivative and how the slope of something compares to what's called the derivative of it, right? The derivative of it. And it's basically the same thing, except the slope in algebra you would say is, well, if you take 2 points, right, and you want to find the slope between them, it's kind of just a line between those 2 points. And it's defined as, your change in the y values divided by the change in the x values. Now the derivative is very similar. Actually, it's basically the same thing. The only difference is, well, over here I have the change in y over the change in x, but where my distance between the x's is really tiny. So like here's my h between my first x and my second x, right? It has just a difference of h. And I am basically saying, well, what if that h is so small that it's almost negligible, it's zero? The reason I say that is because, okay, the slope between these 2 points is that orange line, but the slope at this point is like that, right? That's how much it's changing. It's tangent to the line right there. And likewise, the slope at this point is like that. Okay, they're not the same. They're not the same slope. So I want to find the slope at any given point. That's called instantaneous rate of change. Okay, and it changes at each point, so it makes a difference. So I'm saying, okay, the change in y is basically y2 minus y1, and the change in x is x2 minus x1. Well, what if the change in x is almost zero, right? As the distance between them becomes basically zero. That'll give me almost finding the slope at any given point on the line, okay? Because they're all different. I want to find it at any given point. And that's given by this formula here. So I just said, okay, as the function changes, right, compared to a change in the distance between the two x points, what is that? Well, that's the slope. But what if we take that x to be almost zero? Then that would be the slope at any given point, an instantaneous rate of change. Okay, so we can start this out by defining a function. What is a function? Well, a function is some basic power of x all the way down its subsequent powers to nothingness. So if you have, y equals x squared plus some value of x plus some constant, that could be a function. It goes 2, 1, and this constant is really constant times x to the 0. So we won't really count that. So but before each x, there could be a constant, right? Each one could have a constant in front of it. And the thing is, those constants don't need to be the same. So we'll call this the first constant, we'll call this the second constant, well, this will be the third. And then over here, notice that there's one more constant than there are constants attached to x. So this is constant n plus 1. And this would be the nth constant. And this would be the n minus 1th constant. Okay. That's good for a function of x. Now, compared to that, what would be a function of x plus some h, or a change in x, right? Well, the first one we have would be an x plus h, right? Now that raised to the nth power plus something x plus h raised to the n minus 1. And we move down the line. The constants just stay the same. There's no change in the constants. Okay, so that's defining the function of x and a function of x plus some change in x. Let's not forget what we're really looking for here. We're really looking for this: f of x plus h minus f of x over h. So the first thing we need is this top part. We need to subtract the two functions, okay? So what happens when we get f of x plus h minus f of x? Okay, so it's gonna be this term minus this term right here, right? In other words, it's gonna be c1 times x to the n. Whoops, hang on a second. Sorry, c1 times x plus h to the n, right? Minus x to the n, right? Then it's gonna be the second term with the x to the n minus 1. It's gonna be plus c2 times x plus h to the n minus 1 minus x to the n minus 1. And it goes down the line, and we'll continue that next.